Greatest common factor and least common multiple. So the two questions, they often come up, how do you tell which one is which is the greatest common factor and which is the least common multiple? In GCF problems, we usually have to split things into smaller sections, trying to figure out how many people we can invite, how can we arrange things into rows or groups. So here we have a GCF example. Samantha has two pieces of cloth. One piece is 72 inches wide and the other piece is 90 inches wide, and she wants to cut them both in strips that are equal width and are as wide as possible. So I'm going to be taking the 72 and cutting it up, and the 90 and cutting it up, and the pieces of fabric that I'm going to have left, I want them to be the same size. So one way people do GCF questions is they write the factors of the numbers. So you would write 1 times 72, 2 times 36, 3 times 24, etc. But a hazard with this method is that if you're not really great at your multiplication tables, or you don't know, you skip one, you might be skipping the one that's the answer, and then you get the whole problem wrong. So I think an easy way to do this kind of problem is to use Euclid's ladder. So I'm going to take 72 and 90, and I'm going to put them in an L. And I'm going to figure out what number will divide into 72 and 90. Well, I know that 72 is 8 times 9, and 90 is 9 times 10, so I'm going to use 9. And 9 times 8, like I said earlier, is 72. And 9 times 10 is 90. So 9 is a factor of these. But I can also factor out these guys. So 8 and 10, they're both even, so I know I can divide them by 2. And 8 divided by 2 is 4. And 10 divided by 2, that's 5. And these don't have any common factors except 1, so I know I'm done with my problem. So the answer to the problem lies in two places. This is the first answer. So it's the greatest common factor, so factors we multiply together. So I'm going to multiply my 9 times my 2. And 9 times 2, of course, is 18. So Samantha can cut strips that are 18 inches wide. And here's another interesting thing about doing a question like this. One of the strips, she can cut 4 strips from the 72-inch piece of fabric and 5 strips from the 90-inch piece of fabric. So not only do I know how wide those strips are going to be, but I know how many I'm going to have. And if I add them all together, I would have 9 strips, or I could say I could have 4 if I said that this was green fabric and this was red fabric. I'd know that I'd have 4 pieces that were green and 5 pieces that were red. So using Euclid's ladder to figure out a GCF problem is super helpful. Okay, and then the second question is an LCM question. So LCM, you have to figure out, is it going to happen again and again and again? Are we going to have to get multiple items? Are we trying to figure out if something will happen at the same time? So multiples are the multiples of the number, like 5, 10, 15, 20. So if we're looking at this problem, and we've got Ben who goes to his grandmother's house every 12 days, and Isabel who goes to her grandmother's house every 8 days. They both just visited their grandmothers, so the question is how many days will it be until they visit their grandmothers again on the same day? So when you're talking about multiples, you list your multiplication table. So the first day that they visit their grandmothers is day 12 and day 8 for Isabel. So that's her first day. Ben's second time he goes to see his grandma is day 24. The third day he goes is day 36. And I'm getting these by listing the multiples of 12, 24, 36. Second time Isabel goes, though, that's after 16 days. And then the third time that Isabel visits her grandmother, that's after 24 days. So if I look at my two lists for when they're doing it both on the same day, I see that they're both going to see their grandmothers on day 24. So the answer to the question then would be, when would they visit their grandmothers again on the same day? In 24 days from now. So I hope that this was helpful to you, and that you are able now to better do a GCF and an LCM problem.